Hey there, everybody. This is our second lecture for the material on Exam 4 as we are working our way through Chapter 7. Remember last time we discussed what air masses were, where they formed, and sort of what their different characteristics could be. We said we have hot and dry air masses, we have cold and dry air masses that extend over a really large portion of land or sea surface. But at some point, those air masses do come to an end and maybe change into a different kind of air mass. And so today's lecture is going to focus on what happens at the edges of the different kinds of air masses, and where we see those edges of air masses are where we find what are called fronts, or more simply, the transition zone or boundary between two unlike air masses. In the simplest of terms, or the most general terms, we could say that a front would exist between the boundary of a very cold and dry air mass versus one that is much warmer and much more humid. Here's the most important factor about fronts. Thinking about as we look ahead when we're going to be identifying these on weather maps and thinking about what kind of weather is happening where these fronts are located. All fronts are the site of rising motion. And we've said this for, it seems like every single class this keeps coming back up. But what happens when air rises? It cools, it condenses, it can form clouds, which can lead to precipitation. So in general, we could say that wherever we find fronts, whether it be a cold front or a warm front or an occluded front or some other kind of boundary, we typically find precipitation. It may not be a lot of precipitation, it may not be widespread precipitation, but there's a pretty good bet because we have rising motion happening there that we will have resulting clouds and maybe even precipitation where we find fronts. And the strength of that rising motion, and therefore the intensity of the precipitation, the duration, the coverage of precipitation, that all depends on what kind of front is in existence. And we'll talk more about that here in just a second. Also, fronts are the site of temperature, pressure, and humidity gradients, as well as changes in wind direction and sometimes even wind speed. All of those factors come together to produce the different kinds of changing weather that we find at fronts. And that's really what this is all about. Because when a place is under the influence of a large air mass, say, think about in the summertime when it's hot and humid, and that type of weather can last for days, if not weeks in some cases. But when do we see a change in weather? Well, that's what happens when a front passes through. One air mass moves out and another one, very different, moves in and changes the weather that we experience. So let's define the different types of fronts in a very general sense that we will discuss here in this class. A cold front forms where advancing cold air meets and displaces warmer air. So you have an air mass that is warm and maybe even pretty humid, and it is replaced by one that is much colder and much drier. A warm front forms where an advancing warm air mass meets a cooler air mass, which is a little bit different of a situation than a cold front. But what happens when neither the cold air mass or the warm air mass are sort of facing each other or aggravating each other? Well, when that happens, we have cold air right up next to warm air, but neither air mass is moving. We have a stationary front. And the word stationary obviously meaning it's not moving or it's moving very, very slowly. An occluded front, which we won't talk too much about in this class, that forms when a cold front overtakes a warm front, and you'll hear more about this when we talk about mid-latitude cyclones in the next video. And finally, a dry line is another very important front or surface boundary, and this occurs between hot and dry or continental tropical air that we looked at last time, and hot and humid air or maritime tropical air that we also talked about last time. And a dry line is very important because it is often the site of severe weather, which is a huge topic that we'll cover in the next video. So how can we identify these different types of boundaries on weather maps? Well, we might want to look for differences in pressure, differences in humidity, or differences in temperature, but we first need to understand what the symbols of each of these fronts looks like. So let's start with the cold front first. That's going to be signified or indicated by a solid blue line with solid blue triangles all on one side of the line. Here's the other important piece of this. The direction of those frontal symbols, or in this case, the triangles, that's showing you the direction in which the front is moving. So in this case, this hypothetical example, if you will, this cold front would be moving from towards the top of the screen down towards the bottom of the screen. Or if we wanted to throw some directions to this, we would say that this front looks like it's moving generally from about the northwest direction down towards the southeast. And that's typically what happens because it's colder the farther north you go, just based on latitude. It would make sense that cold air is going to be moving south versus moving from the south towards the north. That typically doesn't happen. But a warm front, conversely, is a solid red line with solid red half circles, all on one side of that red line. Here again, the direction of the symbols indicates the direction of movement. So in this case, the warm air, and let me actually show you exactly what this is meaning here. So in this case, we would have warm air to the south or on the bottom side of this particular front, and it's moving towards the north or moving towards the top of the screen. A stationary front is sort of a combination of the cold front and the warm front. Notice how we've got the half circles, the solid red half circles on one side and the solid blue triangles on the other, and they're sort of in opposing directions, and that's because neither of those air masses, the warm air mass to the south or the cold air mass to the north, neither one of those is moving or directly converging with one another. I love this map here because this puts pretty much everything we've talked about up until this point together, and I really think it makes a whole lot of sense, and it also puts together those notations of the different air masses that we looked at in the last video. So here we've got a system of warm fronts and stationary fronts and cold fronts, even an occluded front there over Minnesota, all associated with an area of low pressure, which is right near the border of South and North Dakota. So the first thing we could look at is let's verify that these wind arrows make sense based on what we've learned about before. And they do. I see a counterclockwise motion and I see air flowing inward toward that low pressure system. But what I want you to notice here is that in what is called the warm sector, we've got this big area of warm air, warm humid air, in fact, because it's coming right off the Gulf of Mexico, which we saw last time was a huge source region of maritime tropical air, hot, humid air that we experience a lot here in Alabama and over much of the eastern 2/3 of the country. So this warm, moist air is moving to the north, and notice at the leading edge of that, we have a warm front. Okay, so we have a warm air mass here lifting to the north, and we see that our frontal symbols are indicating that direction as well. To the north of the warm front, we've got relatively cooler air, maritime polar air from the far northwestern Atlantic, so much colder than the warm, humid air to the south and west. Notice here, coming down from Canada, we've got continental polar air. And we talked about how Canada was a source region for that continental polar air, which in the wintertime is very, very cold and very, very dry. And so look at how the cold air is moving from the north towards the south. And at the leading edge of that continental polar air, we've got a cold front that is advancing toward the south and east. And then we can also see out towards the western part of the country, we've got a stationary front and a weaker cold front where we've got the boundary between the maritime polar air from the Pacific and the continental polar air that's moving down from the interior of Canada and the far northern US. So let's look at what kinds of weather happened before, during, and after each of these kinds of fronts. And we'll start with a warm front. And I want to read this entire table to you, and so you'll be able to take notes as we're going along here. So we see the weather elements here on the left-hand side: temperature, wind, clouds, precipitation, pressure, and humidity. And we've got before, during, and after. So this is with a warm front. And as we go through this, I want you to sort of be thinking about this image as we go through this and sort of apply what we're going to talk about to that image. So before the passage of a warm front, the temperature is going to be cool or cold. As that front passes, the temperature starts to rise, and after the front is totally out of the area, the temperature is going to be warmer. All right, so let's go back and look at this map just for example. Let's think about point B right here, okay? So this looks like it's over northern New Jersey, pretty close to New York City. Right now, it's in the cool air mass, the maritime polar air mass. But let's say in 3 to 6 hours, this front is going to be moving through, and where the temperature was much colder, it is now going to be influenced more by the warm maritime tropical air. So the temperature is going to increase. The winds before the passage of a warm front are typically out of the east or southeast. And then after the front passes, those winds become south or southwest. That has more so to do with the position of the parent low pressure system, but there is a noticeable wind shift as a warm front passes. Let's jump down to the precipitation, because typically with a warm front, you find the greatest amount of precipitation, even though it's usually not very heavy, but you find the most extensive precipitation typically ahead of the warm front. And so before the passage of a warm front is when you typically find the light to moderate rain, snowfall, even freezing rain if the temperature is cold enough. And you can, in some cases, get heavy rain during the warm parts of the year. And then once that front passes, you typically don't have a whole lot of precipitation until the cold front then moves across your location. You can see how the pressure changes before and after the front moves through, and also how the humidity changes. And you don't typically see a huge change in humidity as a warm front passes through, but whenever you do see a change, it typically goes from being cooler, where it doesn't feel as humid, even though the relative humidity might still be high, to after the front passes, you can definitely feel that increase in humidity. So let's look at these two illustrations here. Both of these are showing essentially the same thing, a warm front passing through an area. What we're noticing here on the far left-hand side, and let's look at the first illustration, figure A, for example. We've got warm air to the left, and you can see the cities down here on the bottom. So we're looking from basically south to north in this case. So warm, stable air is moving to the north into relatively cooler air. Now, here's one of the reasons why we typically don't have extremely heavy precipitation with a warm front. So as the warm air moves into the cooler air mass, what you're seeing here is, and this is very, very important, so I want to make sure you can see this, the warm air begins to ride up and over the cooler air right at the surface. All right, so we have cool air at the surface, warmer air higher up or aloft. This situation is termed overrunning, and that can produce widespread light to moderate precipitation. There are some instances where if you have conditionally unstable air or during a certain time of the year, you can get some heavy precipitation and even severe weather in some cases. But more times than not, the intensity of the rain ahead of a warm front is not going to be all that heavy. Even though it might be very widespread, it's typically not very heavy, just because of the motion of the air. It is more gentle. The gliding upward is more gentle. It's not a vigorous, violent uplift that you typically see with cold fronts that we'll look at here in just a second. So now let's talk about the changes in weather before and after a cold front passes. So the temperature ahead of a cold front is going to be pretty warm relative to what's about to happen. During the passage of a cold front, and I think we've all experienced this at one point or another, we can literally feel the temperature dropping minute by minute as that front moves through. The winds typically go from a southerly or southeasterly or southwesterly position, and then they change to the west and northwest. And once we see that wind shift, that's what's helping bring in that much colder, drier air. With a cold front, unlike a warm front, you typically have the heaviest precipitation, or really any of the precipitation, right along the front. You may have heard of the term squall line before, or supercell thunderstorms. When those form along fronts, they form right along that boundary. So you typically have this narrow band of precipitation right as that front is passing. All right, so let's look at what this looks like in reality. So whereas with the warm front, we talked about how we had that gentle rising motion as the warm air rode over the cooler air. But in this case, we've got this cold air, which is very stable, very dense, very heavy. As it is moving into the warmer air, it is literally displacing that warm air and lifting it up. And what happens when air rises? Cools, condenses, forms clouds, forms precipitation. But in this case, because the rising motion can be so vigorous, and the warm air out ahead of this front could be so unstable. This is the situation where you most routinely have the heaviest precipitation, the risk of severe weather, the really, really tall thunderstorm clouds here, and the very, very heavy precipitation. So in general, we could say that typically with cold fronts, the precipitation is heavier than with warm fronts. Not always, but in a lot of cases, you're going to see heavier precipitation, more intense, more violent storms with a cold front than you will see with a warm front. Now, this next type of front is really, really fascinating, especially when we consider the risk of severe weather. And it's called a dry line. And the symbol that you're seeing in the upper right-hand portion of the screen, that's what a dry line is going to look like on a weather map. Now, I will tell you in this illustration, I don't have those half circles colored in. In some cases, they will be colored in, but it's going to mean the exact same thing. Typically, it's going to be a yellow or some type of a shade of brown line with those half circles all on one side, very, very close together. So a dry line is most common in the spring and summer in the southern Great Plains. And it's easy to pick out a dry line on a weather map because we can look for sharp differences in dew point on either side of this boundary. Remember that a dry line is the separation between the warm or hot and humid air and the hot and dry air, so the maritime tropical and the continental tropical air. And so typically what we see is a dew point value that is going to be higher ahead of the dry line where that maritime tropical air mass is. Remember, that's a humid air mass, so our dew point values are going to be higher. And we find much lower dew point values where the continental tropical air is, or behind that dry line. And the difference in humidity results in lower temperatures ahead of the dry line and very, very hot temperatures behind it. So we can also see in a lot of cases a difference in temperature. It's easiest to pick out the dry line when you look at a measure of humidity, such as the dew point. But in a lot of cases, we can also see a pretty noticeable change in temperature because the humid air, the air temperature is not able to get quite as warm as the air that is much drier. We're able to get to reach a higher temperature. So we typically find hotter temperatures behind the dry line and relatively cooler. It's still going to be very, very warm, if not hot, but relatively cooler temperatures ahead of the dry line. And again, with regard to severe weather and convective storms, we typically see the dry line being a powerful or a trigger of powerful violent storms. And the big, big tornadoes that we see in the southern Great Plains typically happen near or just ahead of dry lines. So I love this map here again because we can see where the position of the dry line is, and we can see that ahead of the dry line, we've got southerly winds off the Gulf of Mexico. This is the state of Texas. Here's Oklahoma. Here's northern Mexico. This blue here is the Gulf of Mexico, which is the source region for the maritime tropical or hot and humid air. And so look at our weather symbols or our weather station plots here that we learned several weeks ago. We see the temperature, we see the dew point, we can see the wind speed and direction, and the amount of cloud cover. Remember, our dew point is the lower left number in our station plot, and we see values in the lower 70s and upper 60s ahead of this dry line. But look back behind the dry line. We've got values in the mid 30s, the lower 30s, even the mid to the upper 20s. So very, very dry air behind this dry line because this is where we have the continental, which is drier, tropical air. Also notice in this case, we do see a pretty noticeable difference in temperature, whereas we have upper 80s and lower 90s. We've got upper 90s and lower 100s behind the dry line. So as I said before, in a lot of cases, there is a noticeable difference in temperature along with a very, very clear distinction or change in the dew point values ahead of and behind the dry line. So let's do a little exercise together here. This is from Wednesday, March the 25th, when I'm recording this video. And this is a map of Oklahoma showing current dew point values as of about 5:40 p.m. So I want to ask you, where do you think the dry line is located in this example? So first, let's look over the eastern part of the state, or really much of the central and eastern part of the state. We do see that there are some subtle changes in the dew point values ranging from the upper 30s to the upper 50s, even some lower to mid 60s down in the far southeastern tip of the state. But we don't see any sharp changes we don't really see what we would term a dew point gradient, a change in dew point, a big change over a short distance over the eastern part of the state. However, when we start to look towards the western part of the state, especially as we get closer to the Oklahoma and Texas panhandles, we can see a very, very clear, almost a dividing line, this clear boundary where we have higher values on the right-hand side or the eastern side and much, much lower values on the western side or behind the dry line. So where did you draw your dry line? Hopefully somewhere right about there. Because notice how, as I go back, you can see in this one county here, we've got a value of 47, a value of 48, and then just maybe 15 or 20 miles away, we see a value of 16. So that's a huge change over a short distance. And it's very, very clear in this case that our dry line is located over the far western part of Oklahoma, which is where it typically sets up during the spring and summertime. So that's a little bit about the different kinds of fronts that we're going to look at. I want you to be able to identify those on weather maps based on the symbols, but I also want you to, if I were just to throw up a map of temperature or a map of dew point, could you figure out where these boundaries are based on the differences in temperature and dew point or wind direction, for example? In our next video, we'll see how these different fronts work together as a part of a larger mid-latitude cyclone, which is what brings the changing weather to much of the mid-latitudes in the westerly wind belt. We'll also talk about tropical disturbances, hurricanes, tropical storms, and what a lot of people love about this class, we'll talk about localized severe weather, so thunderstorms, lightning, tornadoes. We'll even look at specifically what big tornado events have affected us here in the state of Alabama. And we'll look at a lot of videos and a lot of pictures of some of the damage. And so that will be coming up in the next video. I do want to remind you very quickly that the exam 4 that we'll be taking, the last exam of our semester, will be administered via Blackboard on Wednesday, April 15th at 3 p.m. on the computer, obviously. So just like exams 1 and 2, you will need a computer, you will need internet access, and you will need everybody's favorite Respondus lockdown browser. So until next time, take care.